All right, welcome back. We're going to test a couple of series now. We'll try and do two in one video here, determining the radius and interval of convergence. This time we have an alternating series. And so when we have an alternating series, it's really important to notice we are going to be testing for absolute convergence first. And so when we use the ratio test, you'll see us using absolute values throughout here at first. And we're once again going to be looking at the ratio test where we want the k plus first term divided by the kth term to have a limit less than 1. And because we're going to be testing for absolute convergence, we're not going to be writing the alternating portion of the general term here. So the k plus first term is going to be x minus 2 to the k plus 1 over 4 to the k plus 1. And the reciprocal of the kth term will be 4 to the k over x minus 2 to the k. And let's go ahead and rewrite it one more time where we bring the common or the similar parts together. And so that means we'll be bringing the x minus 2's together here. And we'll bring the 4 to the power of k, or k plus 1. We'll put those together over on the side. And remember, we want this limit to be less than 1. I should have put that the first time. And now let's just simplify each part with the exponent properties. I've got an extra power of x minus 2 on this one on the numerator side. And so reducing this would reduce it all the way down to just x minus 2 to the first power. Because, for example, if k were 5, this would be x minus 2 to the 6 over x minus 2 to the 5. We'd be able to cancel all but one of them. And on this side, similar this time, but the extra power of 4 is on the bottom. So this would divide down to just 1 over 4. And so my final expression I'm just going to write as x minus 2 over 4. And notice that the k is now completely absent from this expression. So I really don't need to have the limit there anymore, because this expression is going to result in x minus 2 over 4 no matter what k is. And so I'm now going to rewrite this again by splitting the absolute value to just the top, because the bottom is 4 and the absolute value of 4 is 4. And so what this allows us to do is multiply both sides by 4, and we result in the expression x minus 2 has an absolute value less than 4. And remember, this was the key expression that we're looking for. We should have pointed this out at the beginning here, that this expression x minus 2 to the k, that's the x minus a to the k, telling us that the center of the polynomial is the value x equals 2. And now down here, I've got the expression x minus 2 has to be less than 4. And that's telling us now that any value of x that is within 4 units of 2 will cause this series to have absolute convergence, therefore convergence. Okay, so this tells us that the radius of convergence is 4. And if I want to build the interval of convergence, I will write that expression this way, that x minus 2 has to be less than 4, and at the same time has to be bigger than negative 4. And so you can now solve for x by adding 2 to everything. And that means x is less than 6 and greater than minus 2. So this is now the interval of convergence. Now, I mentioned in the other video that some series might converge also at the endpoints of the interval. So we're now going to actually check to see if I can put an equal sign on either side of this inequality by plugging in negative 2 and then plugging in 6 and seeing if this power series becomes a convergent series. Now, this check usually involves writing the general term with those numbers plugged in, and we're hopefully going to just recognize pretty quickly using one of our other convergence tests, or maybe just recognize it as one of our special series that we know that the series converges or diverges. So we're going to be making a note here. We're checking endpoints. So the first one is x equals -2. Remember, go up to the general term and just replace the x with -2 and then rewrite the series. So there would be an alternating series, x -1 to the k. Now that term, that expression x minus 2 is now going to become -2 minus 2, which is -4 to the k over 4 to the k. So I want you to recognize now that in the general term, -1 to the k times -4 to the k would become +4 to the k. And so I could write this 4 to the k over 4 to the k. Now without rewriting again, you notice that's just equal to 1. And so this series is going to be going 1 plus 1 plus 1 plus 1, which is definitely diverging. I'm just going to write the abbreviation diverges. So the left end of this interval is already good. It has to be x has to be greater than -2. It cannot equal -2. So on the other side, we will check the x value 6. Again, replacing that for x in the general term now will be 6 minus 2. And so this is -1 to the k times 4 to the k over 4 to the k. The 4 to the k is just right away cancel. This is now just the series -1 to the k. And since k started at 0, this is going to be going 1 minus 1 plus 1 minus 1 plus 1 forever. And that's an alternating series where the general term does not shrink to 0. So therefore, this is also diverging. So the right end of the interval is also good at the way we had it. X must be less than 6. So now we'll just circle that. That is our interval of convergence right there. Well, let's try and do the other one real quick here. I've got the general term k factorial times x to the k. Let's just jump right in here with the ratio test. We want the limit of the k plus first term. So that would be k plus 1 factorial times x to the k plus 1. And this time we're just going to divide that by the general term, k factorial x to the k. Remember, we want that to be less than 1. And now, instead of splitting this, we can imagine that if we did split it, there would be k plus 1 factorial over k factorial. That results in just the expression k plus 1. Okay, so we're just going to do that. And then the other side has x to the k plus 1 over x to the k. We can reduce that down to just x to the first power. And so what we need to have happen here is this limit is going to be needing to be less than 1. But now we imagine, okay, x could be chosen to be any number we want. If x were chosen to be 0, if x were 0, the expression here would always be 0, and of course the limit would be less than 1. However, if I pick any other value of x other than 0, like say even if I pick x equals 2, this would now become k plus 1 times 2, and if k becomes infinite, this limit is going to be infinite. It will not be less than 1. So this limit will be less than 1. The only way to make this limit be less than 1 is if the x value is 0. So I'm just going to make a note of that here. X equals 0 is the only value of x that I can pick that will make this limit shrink down to be less than 1. Any other number for x would be multiplied by an infinite quantity, and the limit would never be less than 1. So this is kind of case number 3 here. There is only one value of x where the series converges, and that's actually at the center point. We should have noticed that at the beginning, that the center of this polynomial actually is 0. And so this is only a single point convergence. There is no interval. The radius of convergence is 0, and there is no interval of convergence. It's just a single point.